inverse property on the left, it's in logarithmic format, right? The inverse property on the right is more of an exponential format. These are not formulas. And in fact, the property right here that's highlighted, it doesn't need to have it equal to x. That equal sign could actually just be removed, and then underneath this, you could show that it just becomes x, all right? So the way this really works out is, and it's you recognizing this. So you have log base b of b to the x, right? If you have a logarithm where the base of the logarithm is the same as the base in the argument of the logarithm. This is an inverse operation, okay? Meaning that it's just going to undo itself, and you're literally on the left side just left with the exponent, which in this case is x. Which is why I have it equal to x here, but this isn't like a formula you would use. If you recognize this, then it undoes itself, and you're just left with whatever the exponent is. So when I say inverse operation, maybe to help you, let's just take the x, x squared, right? What's the inverse operation of squaring something? Square rooting, right? So if I took the square root of x squared, what am I left with? X. That's pretty much what's happening here, right? Log base b of b to the x is x, right? The justification for that, if you think about what a logarithm is actually doing, or what a logarithm actually is, right? B, right? So this log is basically saying base b raised to what exponent, right? Right now I'm calling this x, this could be a question mark, right? Base b raised to this exponent over here is equal to the argument inside, right? So base b raised to what exponent is equal to the argument b to the x. Using the concept we just worked on in the warm-up, then the question mark must be what? That's that's just kind of lightly justifying why this inverse operation works out. Okay, now put it into an application. Log base 4 of 256. Oh, I don't see base 4 in the argument, so I can't use it, can I? I can use it. Right? So this log here is basically asking us base 4 raised to what exponent is 256 to the m, right? But 256 to the m can be expressed as a base of what? 4 to the what? 4 to the 4th. This is purely coincidental. There's a lot of 4 showing up, all right? But we're kind of looking at it as log base 4 of 4 to the 4th to the m, right? Which is really log base 4 of 4 to the 4m exponent, right? So you want to be able to recognize, hey, base of the logarithm is 4, which is identical to the base of the argument, which is 4. That's an inverse operation. You're just left with what? 4m. 4m. Right? Okay, here's another way to look at it. Now, because now that you're learning more properties, there's going to be different steps that you all can take to make sense of things. So coming off of this line right here, before we go to that line, if we were looking at this one as a different color here, if we were looking at it like this, log base 4 of 4 to the 4m. Instead of using that inverse property, we could also use the power property, where I can take this exponent out front, and I have 4 to the m times log base 4 of 4. We started talking about this yesterday. Log base 4, just this piece right here. Log base 4 of 4 think about what a logarithm is. It's basically saying 4 raised to what exponent is 4? 1. This entire thing is 1 times 4m equals 4m. So you can answer this question with the inverse property, which I showed you first, or you can answer this question with the power property. Doesn't matter. Making sense? Okay. The other one's a little bit more complicated sometimes, especially on the justification part, but it's still an inverse operation. So I'm not going to say, when I asked you about the x squared and the square root here, I'm not going to say there's a particular order here, but you all seem to understand that a square root undoes an exponent of 2, and it's an inverse operation. But at the same time, I could give you that inverse, but in a different format. I could say square root x, what undoes a square root? A square. So if I squared this, what am I left with? Those are inverse operations, just in a different perspective. One, it's a radical first and then squared. The other one, it's an exponent of 2, and then it's a square root. That's kind of what's happening between these two properties. On the right side here, this is expressed as a power. Base b, and then the exponent here is a logarithm. And the logarithm is in the same base as the base of the power, right? So anytime that happens, right, where the base of the power is identical to the base of the logarithm, that's an exponent right now, that's an inverse operation, and it will always leave you with the argument in the logarithm. That's the exponent. So it just becomes x. One way to help you justify this also is if you started kind of like fresh again, base b to the log base b of x equals something. I'm going to call it a question mark. Could be a, doesn't matter, right? This is a power right now. This is what it equals, above, sorry. But if I wanted to rewrite this as a logarithm, I'd set up an empty log. Log base something of something equals something. So the base of the power, in this case is b, is going to transform into the base of the logarithm. And then the log concept is base b raised to this exponent over here. Well, in the power above it, what's base, the red b being raised to? Log base b of x, right? Make sense? So again, it's base b, the red b here, to the exponent, log base b of x, is equal to question mark, right? You with me? So if this is true, now this property is it's the same property as the property you've been working on, right? 2 to the a equals 2 to the 5th. A must be what? Right, this is a logical concept. If 2 to the a equals 2 to the 5th, then a must be 5. Same concept here, but this is the logarithmic format. If log base b of some number, which is the question mark right now, is equal to log base b of x, then the arguments must be equivalent to each other. So the question mark must be x. So this is just a way to help kind of justify why this property breaks down to x, which is the argument of the logarithm written as an exponent. What are your questions? So there's another one down there. 3 raised to the log base 3 of 32 to the m. Sorry. Right? So what you want to pick up on is that the base of the power, 3, is the same as the base of the exponent, which is a logarithm. Right? So if those bases are the same, we have an inverse operation happening. So we're left with just the argument, 32 to the m, and that's it. You don't need to justify the inverse property. I'm giving you the property. If you recognize the property, you can basically just say, it's no different than saying the square root of x squared is x. You never needed to justify that. Same concept here. You don't need to justify it. It's just the argument, 32 to the m. What are your questions? All right. So that's all I had instructionally for